Hello. In this video we're going to take a look at how we can repurpose the Hobby King transmitter here to use our Arduino and RF24 module. And I've already made a video where I constructed this one here, and basically the insides of this electronically at least are the same as what I'm going to put in here. In fact, I'm actually going to take most of my stuff out of here and just transplant it into this box. So you can take a look at that video if you want to know some of the details about what's going on. And in this video I'm just going to go over the things that are different really to what I'm doing, to what I did last time. And the things that are different mainly are that I'm also going to implement these two switches and the two extra analog dials up here. So we're actually going to have 8 channels in total that we can transmit to our quadcopter or car or whatever. So we could use those to turn some lights on or something like that maybe. And the other thing that's a bit different is we have a battery pack included in here, and there's a circuit board in there already. So I'm just going to show a little bit of the details about how where I'm connecting to that circuit board to source my power for my Arduino from. Just before I do that though, I should mention that after my last video where I was saying I had a lot of trouble getting this to work, fortunately this nice person, the electric, where are we? This fellow here came to my rescue, and he pointed out some links, one of which was this link here, which we'll just have a quick look at. And this document here has been made by somebody who is putting a Bluetooth module into this transmitter so that they can do programming of it wirelessly. And the guy has his email address here if you want to get in touch with him. And as I was scrolling down here, I realized pretty quickly that the Hobby King cable that you can get, that I was saying that I might have to get to connect to this transmitter, was not actually necessary at all, because it's basically just a serial connection on the back of the transmitter. So that is this connection at the back here. You can use your regular FTDI adapter to connect to that. And the way I did it was a bit rough, but I found that you can just use breadboard connecting wires like this and poke them into the pins there. So that would be that particular pin there would be either RX or TX, I'm not too sure. So just to look at the pins here, the bottom two, this one and that one, will be RX and TX. The one on the upper right will be plus 5 volts, and the outer ring will be ground. So you can just use those 4 connections to connect this up to your computer, and then you can use the regular config program to connect to it and set up the endpoints for the sticks and everything. Unfortunately, I've found that the config program is, to put it charitably, dog shit. That's the nicest thing I can say about it, unfortunately. I did eventually manage to get it to work well enough that I could do a short flight with using this transmitter and the regular receiver that it comes with, the original Hobby King receiver that it comes with. But yeah, it wasn't fun using that config program. Basically, every time I touched some kind of config, I would either lose functioning of one of the sticks or the other, or something would just go out of whack. So you can actually find different config programs that other people have written. Surprise, surprise, when there's a crappy one, somebody makes a better one, don't they? So you might like to try those if you're still interested in using this transmitter as is. But like I say, after I did my first little flight just to confirm that I had got everything working, I basically just left it at that, because my whole purpose for getting this was to convert it to Arduino anyway. Another thing I should probably mention is that once I eventually found some nice potentiometers to use for these joysticks, I could actually fly the quadcopter with this transmitter no problem at all. So what I'm doing is not really necessary. It's nice to have these extra dials and switches, but if all you're really looking to do is 4 analog channels just to fly the quadcopter, then something like this, if you can manage to build something like that, it's just fine. And I found actually that it's not such a bad thing not to have the yaw returning like that. I found it flies just fine like that, no trouble at all. And I've actually become quite fond of this little wooden box transmitter now that it's working properly, so it's going to be a little bit sad to see it go, I think. It's always a novelty to take to the flying field, and people think I'm very smart for having made the transmitter as well, which I'll just let them think that. One thing that is a bit of a weakness though that I found with this is that the joysticks don't go into the corners of the range completely. So when I'm using multi-Wii, at least I think most flight controllers use like something like down and yaw right to arm the flight controller, and this joystick can't do that. It can't get fully down and right into that corner position. So what I have to do to use this to fly is I use my other transmitter, turn this one off of course, and I use my other transmitter just to arm it like that, and then turn that transmitter off, turn this one on, and then I can fly using this one after it's armed. So that is a bit of a weak point, admittedly, but I think that's the only weak point that I've really had with this. Anyway, let's put that to the side for now, and we'll get on with looking at this one. Now, you may, if you're observant, you'll notice that the antenna is missing. That's because I've actually already got started on this a little bit. So let's just open this up if we can, see what we've done so far. Basically, I have just cut all of these wires that lead up to the switches and the dials, so they're all completely separated now. I can put them up like that, and I've actually cut the wires to basically everything else as well, leaving them as long as I can get them still. And that means that I can take this board at the bottom, and that just comes right out. So all I'm going to be using this for is basically just a power supply, and of course it has a switch on there, which is handy, and also has the LED here to let me know when the battery level is getting low. So I want to keep those points of it, but basically everything else on here I'm not really interested in. So that leaves us just with a bunch of sensors, I guess you could say, a bunch of potentiometers, and the switches. So I just want to have a quick look at the circuit diagram and see what's different to what we're going to be doing with this to what we did last time. So last time, as you may recall, we had the two budget joysticks like that, and we had to give them some positive and negative reference, and we were taking the wiper signal line from those into analog pins 0, 1, 2 and 3 like that. So basically we're going to be doing the same thing with the joysticks, the new joysticks. We give them a same kind of a reference point there using VCC and the negative, and we take basically exactly the same kind of situation there. The way I've drawn it here, it looks like each joystick has two signals, but there's actually two separate potentiometers for each joystick. This just stops things from getting cluttered up because we're going to draw a few more things here. So we also have the two dials, and they are basically the same as the potentiometers in each joystick. So they need a positive and negative reference, and they also need an analog input on the Arduino Pro Mini, and I'm going to use these two pins here, which are pins 6 and 7. What can I draw on here? Oh, excuse me. Pins 6 and 7. One is 6 and one is 7. I'm not sure which is which. I'm going to use 6 and 7 rather than 4 and 5, which are here, because 4 and 5 are the I2C lines, which I don't really have any plans to use, but I'd like to keep them free just in case I change my mind at a later date. So that's the dials, and for the switches we do something pretty similar. The switches are, all they need is a digital input, so I'm going to use pins 2 and 4 for those. You can use any of the pins between pin 0 and pin 8. Remember that pin 9 is going to be used for the RF24 module. So any of the pins between 0 and 8 should be okay. I'm using 2 because pins 0 and 1 are here and they are RX and TX. And if you have a lot of switches that you want to use, like if you want to use, I think we could manage a total of 9 switches in total if you wanted to use all these pins, because you could use pins 0 through to 8, which would be 9 pins, right? The reason I'm not using pins 0 and 1 is because they are RX and TX, and RX and TX are also over here, and they're used when you plug in the FTDI adapter to upload a new program or to use the serial monitor to see what's going on your computer. So if you really need to use 9 switches on your transmitter, you can do that, but it's kind of a bummer because every time you connect the Arduino to your computer to upload a new program to it, you're going to have to disconnect whatever you had connected on the pins 0 and 1 here. It doesn't mean you can't use them, it's just a little bit annoying. So that's why I'm starting from pin 2 instead of pin 0. And the reason I'm skipping pin 3 is because, as we can see with the white circle around pin 3 is capable of doing hardware PWM output. And I don't have any plans to use that, but just because pin 3 is a little bit more feature capable than pin 4, I'm going to skip over that and use pin 4, which is just a plain digital pin. I don't have any plans to use anything using PWM. It's just a little bit easier if I want to change something later on to have that pin free. Alright, so another thing that's a little bit different with these, let me just clear some stuff off. Alright. With the switches, one thing that's a little bit different that you'll notice is that they don't have any negative rail reference coming into them. And that's basically because if we look at the switches as they exist right now, it's a little bit cluttered, but you may be able to see that that switch down there, it only has 2 connections coming into it, so it's just it's either breaking a connection between these 2 wires or it's joining a connection. Now there is a third tab on the switch that we could use. Sorry, it's all... There we go. So there's a third tab at the bottom that doesn't have anything connected to it at the moment. So what we could do is... where are we? We could bring a negative connection into that pin that's not being used on the switch, and that would give us a negative reference. And the reason that we would want a negative reference is, think about when the switch is closed, let's look at pin 4 for example. Pin 4 would be coming through here, and when the switch is closed it would be seeing the VCC voltage, so it would be high. And when the switch is open, pin 4 would just not be connected to anything at all, so it would be floating. And I had some problems with this in my other transmitter where I did this setup, and I just left it floating. And basically what happens is the result is as if the switch is being switched off and on continuously, which is kind of annoying, and we don't want that. So one thing you can do is like I say, you can use a negative connection using the extra pin on the back of the switch. Or another thing you can do is you can attach some pull down resistors like this. Let me just... Oh. Alright, never mind. You can have a couple of 10K pull down resistors attached between each of these digital pins for the switch and the negative rail, and that will just make it so that when the switch is open, the pins will be seeing, basically they won't be floating, they'll be connected to what is essentially going to be ground voltage, so they'll be fully off. That's what I did last time. That works fine. I think since I'm going to be running some wires to the dials which are right next to these switches, I might just take a little wire from the negative tab of my dials and just connect it to the switch like that, so I can have a proper non-floating connection when the switch is switched the other way. So as you can see from that circuit diagram, all of the positive connections and negative connections, or the the references that each of these potentiometers have, they're actually all joined together. So for example, if I look at one strand of wires coming from this potentiometer, there's a black and a red, and then there's some other color, in this case white, and they're all like that. So there's black and red and some other color, and it ends up being quite a huge scraggly bunch of wires, and essentially all these reds are connected to each other and all the blacks are connected to each other. So what I think I might do to try and keep this a bit tidier is, for example, from this pot here, I would take the red and the black from this one, and I'll connect those to the red and the black on this one and shorten the wire to as short as it needs to be. And then I'll take the red and the black from this one and bring them over to here, and so on, so that they can be sort of daisy chained in a circuit around like that. And then only the signal wires themselves need to be in a scraggly mess coming down to through the middle like that. So hopefully that will keep things a little bit tidier. For the output side, we have, of course, an RF24 module, and this needs a bunch of signal wires like this, and we don't really have much say in how these are set up, so nothing is going to change there. So I'm just going to take those away for now, just to keep things a little bit easier to explain. The RF24 module requires 3.3 volt power, and I've found in the past that that can be supplied from a 3.3 volt Arduino Pro Mini just fine, from the VCC pin like that. That's what I've been doing so far, and I have not had any trouble with it once I got a few other little things right. And one of them is that you can't really take the what is going to be in this case 9 to 11 volts or so of power from the 4 nickel metal hydride AA batteries in this transmitter case. That's going to be about 9 to 11 volts for a healthy charge, and we can't really give that to the Arduino on its raw pin directly. Well, we can, but that means that the Pro Mini is going to have to be dropping quite a lot of voltage on its regulator, and it can't do that and also give enough power to this board here, which is a high power RF24 module. So what I found it necessary to do is use some kind of a voltage regulator. This is the one that I used earlier, and you can drop the power coming into the raw pin to 6 volts is what I've been using for the last few months without any trouble. And with this arrangement, it seems, at least I have never to this point used a capacitor on the positive and negative power pins of the RF24 module, as a lot of people have found it necessary to do. However, I got myself some little caps that I can use to try that. So for this particular build, or instance of the build, I will actually try some caps on this on these two terminals here, just to see if it makes any difference. I'm thinking it probably will not, since I've managed to get things working okay so far. Okay, so 6 volts is what I've been using so far from this step-down module, and what I'd like to do this time is get rid of that and use the 5 volt power that is available from the circuit board that's in this Hobby King transmitter already. So I think 5 volts should be okay, just as it should work just as well as 6 volts as far as I can tell. If it doesn't, I might just go back to using this step-down module anyway. So just to have a look at where we can get 5 volts from on the Hobby King board, we have to look at this side this time. And I would recommend that you get a simple multimeter, just so that you can check that the voltages that you think you're getting are actually what you're getting for this. So we can see there that there's the power is coming in from the battery directly there, and there's the on-off switch on the back. So you'll find that when you switch that switch on, the upper of these terminals will be giving you the full 10 volts or whatever from your battery pack. And you can follow that through, and you'll find that there's a small, of course the wires are getting in the way every time, aren't they? Right here you'll see a very small voltage regulator, and that is regulating the voltage from that 10, 11 volts or whatever down to 5 volts here. And that was what was originally being used to provide over here. You'll see this if you have one of these transmitters. Before you cut the wires off, if you want to go as gung-ho on it as I did and cut everything off, before you cut them off, you'll notice that those wires were coming from, were providing rather, the reference voltage to the potentiometers. So that's what that voltage regulator was used for, and it's 5 volts. So you could use that to as a reference for your potentiometers. Obviously that's what it was originally used for. Now I did discover though, if we turn this over here we have another voltage regulator, much more of a large one here, and this seems to have been used to power the radio transmitter module from the transmitter, which is, incidentally, I of course cut that out as well. But this voltage regulator here is also regulated to 5 volts. So I'm not totally sure why there's the need to have two separate regulators that are both regulating to 5 volts. The only difference between them, I looked up the spec sheets for these two regulators. They're very, very similar. The only difference is that this one can handle a lot more power. So I'm not sure why this one couldn't handle the power for the references for the potentiometers as well. So I'm guessing there may be some sort of I don't know, really. It doesn't seem like there'd be too much noise coming from the pots, but I'm not sure. Maybe somebody could educate me on that. So anyway, what I'm going to do is take the 5 volts that is coming on this side. One of the side pins here will have 5 volts. So I'm just going to solder my Arduino raw power pin onto there, and that will give me 5 volts for the Arduino. So that's pretty much the only connection I'm going to be making between this side and that side, as far as I know at this point. Anyway, so I'll get on with that and get back to you once I've got a little bit more done. Okay, I've connected all the potentiometer terminals up with the red and the blacks going around in a circuit. So basically every potentiometer has 3 connections, and I've just made the outside 2 terminals of each one of those connected to, all mutually connected to each other, so that's including the dials and the switches as well. So that keeps things a little bit tidy. It's still a bit of a scraggly mess down here, but now I have only the 8 non-red and black signal wires coming down here in the general area where I'm going to put my Arduino Pro Mini once I get that in there. I found that you can take these joysticks out completely, which makes things a lot easier for getting in there and soldering the dials and the switches. And I also discovered that 2 of these screws here in the center, upper center, are actually fake screws. They're just plastic for some reason, so don't stress if you break them and you can't get them out like that. A little bit weird, but that's the way it's made for some reason. Okay, I noticed that this video is getting kind of long, so I just went ahead and did everything basically, and here it is ready to be adjusted. So I also wanted to look at the sketch, the Arduino sketch, a little bit more in this video, so I don't want it to drag on too much, but I'll just show you some photos in a second of some points that I thought that were worth mentioning about various things that I did. But for now, we can see that we have, if we turn it on at least, we have the sticks responding, the directions and the calibration is all wrong, but that's what I want to look at next. But you can see that the sticks are working here. The switches and the dials are still not doing anything at this point. So anyway, let's just have a look at a couple of points that I wanted to mention about what I did so far. A lot of the solder on these joints was kind of crusty, so I actually went around and desoldered everything and used some fresh solder to do everything up again. Well, not everything, but just these points here and some other points that were a bit crusty. I actually put the original RF module back in, but only to serve as a mounting plate for the new RF module, so I used some double-sided foam tape to stick that onto there. To mount the antenna, I had to actually cut off a big chunk of the plastic part that was there originally, just to leave a thin piece that's about the thickness of the transmitter case itself. I stuck the Arduino Pro Mini down the bottom of the case here because I wanted it to have the pins facing outwards. You can see I've cut a hole in the side of the transmitter case there. That was because with my previous transmitter it was really annoying to have to open it up every time I wanted to change the program on the Arduino. So this will let me just poke the plugs in from the side. It should be much more convenient. I found that the way I connected up the pins was a little bit space consuming. What I did was I soldered the pins on, but they're still the same connectors. So what I mean by that is I just removed the hard plastic square plug ends off them like this and soldered that on, and then put a bit of heat shrink over it. So it'll make very nice solid connections. But as I say, it makes the pins stick up a little bit high still. So unfortunately, when I put the PCB back on like this, you can see that it doesn't quite fit down. It's actually bent up quite a bit. It's all functioning perfectly okay though, and fortunately it's the left hand side of this is where the charging jack joins on, so that was the most important side. So I used the same double-sided foam tape to stick the Pro Mini on there, and I found this really useful, so I'll just mention a little bit about this. It'll need to be quite thick, so if you can find something like this, and as you can see there, it's actually 2 millimeters thick, so it's quite thick. And the reason for that is, or the reason that you'll need to find something thick, is that you're probably going to have pins sticking up on the rear of your Pro Mini like that. As you can see, that's about 1 millimeter in height there. So the tape will need to be higher than those pins. This is just something else, don't worry about this particular one. But you'll need the tape to be higher than those pins so that you can actually get it to contact onto the Pro Mini and also the thing that you're sticking to it as well, without the pins getting in the way. Okay, so I wanted to just have a quick look at the calibration of these joysticks now that we've put them in there, because I didn't really look at that too much last time, and these sticks do need a fair bit of calibration because they don't go between 0 and 1023 as nicely as the other joysticks that we had. So I've plugged in my FTDI adapter here, and I have my sketch, and it's the same sketch as before, and this sketch just prints out the values of all the sensors that it's seeing. And I've added the 2 more analog channels or values here for the dials, and I have 2 digital reads for each of the switches, a digital read for each switch, and I'm just printing out those values there. So if I upload this and then open the serial monitor, we should see those values showing up there, and I'll just bring this over here so we can see what I'm doing. So throttle is going from 180-ish to about 807 or 810 if I push it that way. 812. So you can see that it's no longer going between 0 and 1023 like we had before. So you definitely do need to do this calibration step to get all this range of values correct before you move on. So we should have yaw going between 100 and 850 or so, pitch, roll, and then the dials. So this is actually dial 1 here, and this one almost does go between 0 and 1023. Almost gets right up there. Dial 2 goes from 29 to 968, and then the switches will just be the 0 or 1. So how do we use these in the transmitter sketches? The next thing we need to look at. Oh, and one other number that you should record at this point is the midpoint of the sticks that return to the center automatically. So that will be the pitch and roll stick and also the yaw value. The throttle is not so much important, but you should also record the center position of the throttle as well. So in this case I have yaw goes back to about 460 when I let it go. Roll goes back to 561 roughly, sometimes a little bit different. Depends what side it comes back from by the looks of it. But this is going to be important because there's not always the same range of values on each side of the stick's range when you're moving it. So you might find that you get, say, 360 values between the middle and the top of the pitch, but you might only get, say, 320 values going downwards. And that's going to become important in the next step when we use these values in the transmitter sketch. So here is the transmitter sketch. We're almost there. So I've expanded a little bit. Previously we just had in our data structure that we were sending to the receiver, we only had throttle, yaw, pitch and roll, and now I've added an extra 2 bytes for one for each of the dials, and I'm using just one single byte to store both of the values for the switches because they only need 1 bit of data. So I'm going to use a bit flag stored into 1 byte for now. This would let us hold up to 8 on-off, simple on-off switches in 1 byte. And in the reset data function, you'll probably also want to set those to some kind of safe default value. I don't actually have any functionality on these at the moment, so I'm just setting them to 0 for now. That part is the same. And then if we come down into the loop function, this is where we start to need to use the values that we recorded just before. So I have recorded my values. So for the throttle there was the this would be the bottom position, middle position, and then the top position. And for the ones that go horizontally, I've recorded them left, middle, right, like that. So you'll need to use those values in the parameters for map joystick values. And what that does is it reads in the value that we're getting from the analog pin, and it'll call this function here that I've made to map this to a value between 0 and 255, taking into account the middle position as well. And the reason that we needed to check the middle position is so that we don't just rely on the lower and the upper ranges of this value only, because that means that when we let go of the stick and it returns to the middle, it might not actually be giving us a value that's exactly the center between these upper and lower values. So that's why we need to specify what the middle is expected to be. So anyway, I'm not going to go into the details, but that's the function there. And this function wasn't in the original sketch that I uploaded when I did the first video for making the transmitter, so I've added it since then after I realized that it was going to be necessary. So yeah, put the values in there, and this function expects, as we can see here in the parameters, this is the value that we're going to be mapping, so that's just coming from the analog read. And then we need to put in a lower, middle and upper in that order. And so you'll see one of my if I look, I think it was this one here, yeah, roll. For roll, I actually had the higher value when my roll stick was on the left. So this is left, middle, right, and my right value is higher. So I need to turn those around to give them to this function. That's why I've given them 165, 564, 906 in that order. And then I have to let that function know that I actually wanted that axis to be reversed. So the last parameter here, reverse, says whether we want that axis to be reversed or not. So there's just one that I had that was like that, and that will just depend which way your pots are giving you those values. It's no big deal to just reverse it like that. Okay, so for the dials, we don't really need to be concerned with the center position for the dials, so I'm just using the normal map function to take the analog value read in and I'm just mapping it between the two largest and smallest extents that I saw on my dial, coming from my dials there, so that's those values, and I'm mapping that to be between 0 and 255, and I've turned one of them round, I think. No, I've kept them the same. And then occasionally you can get a value that is outside this range that we recorded before, and when that happens, this map function can go a bit funny. So what I've done to prevent that from happening is I'm calling constrain, which will take the value that we got from the map function and it will ensure that it is between 0 and 255. So that'll just stop any strange values from coming up. And as for the switches, this is just a couple of digital reads, and to pack them into this one byte as bit flags, I first set the switches bit flag to be 0, so that will clear all the flags, and then we go through our switches one by one and we just check if that switch was on, and if it was on, then we set that flag to be switched on in that bit flag. Now I've actually made this a not on, so I'm checking if the switch is not on, or the pin is not reading a digital high. That's just because I wanted to have it so that the switch reads as being on when it's that way. So that's going to be off and on. So if you want to reverse that behavior, you can just add in a not check here if you like, or take it out, I guess, in my case. So just as a quick confirmation here, I have my trusty test utility thing, and hopefully if we can focus on this. Yep. So it's running at the moment, and we can see I have the throttle is giving me values between 0 and 255, so that's quite nice. Yaw is also giving me values 0 to 255, and then pitch and roll. So this is the third and the fourth values on the left, are giving me values between 0 and not quite 255, but pretty close. Actually, hold on a minute. It should be better than that. 255, 254. It looks like when I push it into the corner, it doesn't quite give me a value of 255 for pitch, but if I push it straight up, it does almost. And so for the dials, that's the two numbers that are 0 at the moment are my dials, and if I turn the left dial, I can turn that up to 255 and back down, and the dial on the right, I can turn that one up to be 255 and back down. So those are working okay. So the last couple of things, when I flip one of my switches here, you'll see an asterisk shows up in the very bottom row. So that is switch number 2 being switched off and on. And over here we have switch number 1. So there we go, that's 8 channels of data, 6 analog channels and 2 binary channels. And everything seems to be working okay. Now, of course, to make use of that on the receiving side, we have to change the sketch for the Arduino Pro Mini that we have on our quadcopter acting as the receiver as well. So to do that, we add the same stuff we did just a moment ago. We have the extra data in our structure for my data, so that's the 2 dials and the switches. And also again, we do the reset data. We have to put something in here, some values that are safe. Now the only other thing we need to do is we have to add some more setting points here for our ppm data. Now notice we're increasing this from 4 channels before to 8 channels now. So you'll have to come up here and you'll also have to change this channel number to 8. Otherwise this array will not be long enough. So all I'm going to do here is for the 2 analog channels, the 2 dial channels that we added. Those are basically going to be exactly the same as for the 4 channels that we had there already. And to make the switches work, I'm going to check if the flag is set for each of the bits that we're expecting to see in that switch bit flag. And if it's set, I'm going to set that to the ppm value to 2000. Otherwise, I'm going to leave it as 1000. So this is a binary off and on as far as ppm is concerned. And I've already uploaded this onto my Pro Mini. So that's not the multi-Wii board itself, of course. That's the Pro Mini that does the receiver part of everything. So that's already on there, and it looks like everything's working okay. If I check my multi-Wii conf board, so now I'm talking about the multi-Wii board. So I have this one here is connected onto the flight controller, and I'm looking at that here. You can see that's what we're looking at. So of course I have the normal throttle and yaw, and if I arm this and disarm it, it works. And then there's roll and pitch as normal. Okay, so everything that we had before is working. And now the extra stuff was on the dials. So I put this one on to aux 1. As you can see, that's that dial. And dial number 2 is on aux 2, like so. And then the switches are on aux 3 and aux 4. So like I say, they are either completely on or completely off. If you get hold of some switches that have like a 3 position or a 4 position setting, you could quite easily incorporate these into your sketch as well. But like I say, these switches are just either on or off, so that's all you can do. But anyway, I'm just charging a battery now, so I might go and take this for a little fly just to make sure that everything is working. And if I do that, I'll put that on the end of this video. If I don't, well, this is going to be the end of the video right here. So we've come pretty much right to the end of everything that I was hoping to get done in this video series. And I'm planning to make another, possibly 2 more videos. One will be how we can use these switches and dials to put some lights onto the quadcopter and maybe control the lights in some way, turn them off and on, make them brighter or dimmer or something like that. And I also want to look at how to make a buzzer so that you can find your quadcopter if it gets lost in long grass, or as in my case, 10-foot tall bamboo. And so that may be another couple of videos. And I've also learned a few things that I might make a video about, just to give you some tips about what I've learned in the couple of months of flying with this quadcopter as well. But as far as building stuff goes for the main part of the quadcopter, we're done. That's it. And thank you for watching this video, and if you watched other videos in the series, thanks for watching those, and do let me know if you try any of this stuff yourself, and yeah, let us know how it goes. Okay, so see you next time.